All right, hello geometry students. We are here with lesson 4.4, something called side, 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 and side angle side, or SSS and side angle side, or SAS. So let's talk about what that is. Overall, we are dealing with triangle proofs in the last 3 lessons of chapter 4, and I think you're going to like what these two terms mean in terms of writing proofs, as much as we can ever like proofs. All right, so let's jump right in. Just 2 definitions. SSS and SAS. And so what SSS stands for is simply side, side, side. Now, what on earth does that mean? Well, what that means is previously when we have been proving 2 triangles, I'm going to draw myself 2 triangles, and we've been trying to prove that 2 triangles are congruent, we were doing a lot of work. We were trying to prove all 3 sides and all 3 angles. And that's 6 things of proof plus hints. So you had these really long proofs like the one we did in class. What side, side, side asserts is that that is overkill, and that in fact, if you take 2 triangles, and I'll go ahead and just write this as, let's say, triangle FGE and triangle HIJ, and what that says is that if I want to prove these triangles congruent, just knowing that the 3 sides are congruent. So in other words, if I know that GF is congruent to JI, if I know that FE is congruent to IH, and if I know that GE is congruent to JH, I don't even need to worry about the angles. Because if those 3 sides are all congruent, then I can automatically know or assume that all of the angles are congruent. So 3 steps are enough. If I can prove, put my 3 in the camera. If I can prove 3 sides congruent, then I know that triangle, we'll say FGE is congruent to triangle, and I want to do it in the same order, so IJH. Okay, and so that's what this lesson's all about, is that 6 pieces of evidence, all 3 sides, all 3 angles, that's too much. Side, side, side is adequate, as is side, angle, side. And so if I have 2 triangles, draw them something like this, a little different this time, and we'll call them STU, and we'll say VWX. So I can prove triangles congruent if I prove all 3 sides. Another option is if I prove 2 sides. If I know that, say, this side is congruent to that side, I know this side is congruent to that side, and I know that the included angles are congruent. Now, an included angle simply means the angle between the 2 sides. So I'm going to note that the included angle is between the 2 known sides. Okay, so we're not talking, so that's why we specifically say SAS, because that means we're talking about side, angle, side in that order. Okay, or it should always it should always be the angle between the 2 known sides. Otherwise, you're not really saying SAS, you're saying something like ASS or SSA, or some different form of that. So in other words, if you have 2 sides that are identical and the angle between them, then everything else has to be the same as well. And you can kind of break that down, but just try it. Try to measure out 2 sides of a triangle and the angle, and try to draw 2 different triangles. If you have the same 2 sides and the same angle in between them, you cannot draw 2 different triangles. You can only draw the one same congruent triangle. Okay, and so as a result of SAS, I could say that here. So triangle STU would have to be congruent to VWX. And so the good news about this is that proving triangles congruent, which we'll be doing for the rest of the chapter, is half the work than what we thought. Not 3 sides and 3 angles, but either just the 3 sides, SSS, or 2 sides and the angle in between, SAS. So let's go ahead and take a look at the questions. And whoops, I forgot to put these up where I could read them. So bear with me. Sorry about that. All right, so here we go. Question number 1 says what I've been saying. Do you need all three angles and all three sides of two triangles in order to prove they are congruent? Yay, the big answer to that is no. That's overkill. Okay, that's too much. If not, what information do you need? Well, our two theorems that we know so far. Stay tuned, there's more to come. But no, what you do need is either SSS, all three sides, so something that looks like this. Those sides, those sides. So if I just know the three sides, that's good. Or if I know side, angle, side. Okay, two sides plus the angle in between. Alrighty, and so then that looks something like this. So you only really need three pieces of information. So the two sides and then the angles in between. So either of those, that's enough information to prove congruent triangles. Okay. And the next couple of questions then have us, I've talked about the other day in class where there's gimmies. That's where, like, say, a proof would just tell you, hey, these sides are congruent, or hey, these angles are congruent. You'll sometimes get gimmies in proofs. Other times you're going to get clues. And so the next two questions are about clues. The first one is, why are bisectors useful in proving triangles congruent? And that is because bisectors, oops, let me get the right color. Bisectors, they create either congruent sides or congruent angles, right? So in other words, if we draw a picture, I'll just, I'll draw it in black. Okay, so say we have this, and we'll say M, N, O, P. And now that looks, sorry, that doesn't look very congruent, but just, I should draw that. That looks horrible. Let's fix that. Okay, that's a little better. But say that MP is the bisector. If MP bisects NO, that is a clue, because that means that MP must be cutting NO in half, which means MP and OP must be congruent. So bisectors are useful clues. When they give you a bisector, you know, either a side or an angle has been cut evenly in half. Okay, so it's a clue. It doesn't prove congruency, but it leads you, it's one step away to a congruency. And that would be the same thing if I kind of even just draw a similar situation. Well, let me just say, I'll write this. MP bisects NO. So notice it's a line bisecting a line. You could have a similar situation. I'm going to do this. And I'm going to change the letters just because. A, B, C, and then D. And they could tell you that BD, so that middle line, bisects angle ABC. Alrighty, and so what that means is that this line here is bisecting this angle up here. And so that means now I get two, not this line this time because it's an angle being bisected, but the angle at the top, which you might think of as just angle B, but we'd call it ABC, that is being cut into two equal halves. And so now I know that I have two congruent angles. So that's what I mean by whenever they tell you something bisects, it's either going to create a congruent side, set of congruent sides, or a set of congruent angles. And always just, if it bisects a line, like my first example, you have congruent sides. If it bisects an angle, like my second example, it bisects an angle. Okay, so that's our first clue. This other clue we've already talked about in class, parallel lines. They're a clue because they create a transversal. And not only that, but a transversal with typically alternate interior angles, because those are congruent. So again, we've seen this example in class a couple times now, where if you say they do something like this, and they've got the two triangles on top of each other, and they tell you, oh, this is congruent to that side. Well, that has created a transversal. Here's the parallel lines, here's the transversal, and you've got the two alternate interior angles here and here. And so again, now I could say that, I guess I should write, let's go ahead and label this thing. We'll just keep it simple, A, B, C, D. But in this case, since AB is parallel to DC, that is then a clue that angle, let's see, BAC, that's this one right here, BAC is congruent to angle DCA. That's this one right there. Okay, so whenever you see parallel lines, you want to think, oh, somewhere they've created alternate interior angles. Just like if you see bisector, they've created two sets of congruent sides or angles. So those are two clues that you want to be on a lookout. Another very basic clue, and we talked about this the other day in class too, is that what congruency principle states that a line or angle is congruent to itself? That is an example of, say, here you've got two triangles and they have, excuse me, they have a common side right here. And so that means that they both share that side. It's the same line. And so, of course, that side line must be congruent to itself. And so we're going to say that is the reflexive, principle. Okay, where you would, again, maybe I'll go ahead and label this A, B, C, D, but that would allow you to say that line AD is congruent to line AD. Okay, and finally, last question number 5. What can help you in making sense of overlapping triangles? This is a real simple idea. This is where like you get a drawing like this, and the triangles they actually tell you to are congruent are something like A, B, C is congruent to triangle D, C, B. And what you can see is that's actually this triangle here and this triangle here. And a lot of kids get confused when all of a sudden the triangles actually overlap each other, because you can see, again, here is one, and then this is the other. All I wanted to point out with this question is that I highly recommend you separate them and that you redraw them so that you have, here's one triangle, here's this triangle, and this is ABC, and this is DCB. All right, so all I wanted to say here is separate the triangles, because then you can kind of more clearly see which triangles you're talking about. When they're overlapping, it can oftentimes be kind of confusing. So just a little tip as we prepare to take a little deeper dive into triangle proofs. Alrighty, so a couple important clues: reflexive, parallel lines, and bisectors. Also the fact that we only need 3 pieces of information to prove triangles congruent: side, 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 and side, angle, side. Alrighty, see you in class, and we'll keep on having fun in geometry. Talk to you soon.